Today we're going to be kind of focusing on rate, time, and distance problems. So if you remember, rate times time equal distance. Rate is like your speed, how fast you're traveling. Time is a length of time, and distance is a length of distance. So here we have Don and Donna, and they're leaving their home at the same time. They're going to go in opposite directions. Don's traveling this fast, Donna this fast, and we want to know how long they're going to be, how many hours they will be, 760 kilometers apart. So again, we're going to put our information in a table, and I am going to make you even draw a little line picture of what's happening, kind of. So in this case, the top of the table is pretty easy because we're doing the rate times time equal distance, so that will be the top of our table. We have Don and Donna, and in this case we don't really need, Donna, we don't need a third column. I just have it on there because I made all my tables the same. So what do we know from the problem? It says Don travels 80 kilometers per hour, so 80. Donna travels 72 kilometers. Now, we don't really know anything about the length of their time, except that they did leave at the same time. So whatever their time is, it will be the same. So we're just going to use x for that. I don't like to use t, but the distance is just these two multiplied together, 80x. And 72x would be the distance traveled by each one. So if we're looking at a line drawing of this, let's say here's their house. Okay, Don is going this way. Donna, it says, is going in opposite direction, so she's going to be going this way. So we want to know when the total distance here is 760, I believe it was. Yes, 760. So what makes up that total distance? The two distances added together. So our equation would just be then 80x plus 72x equals 760. When we add those two together, we get 152x equals 760. Divide by 152. We get x equal 5. And what does it represent? 5 hours. And again, the question is, in how many hours will they be that distance? So 5 hours is our answer. Very important that you read the question because sometimes they ask you different things. All right, let's look at this next one. Here at the same time, Chris leaves Washington, D.C. for Detroit. Amy leaves Detroit for Washington, D.C. So now they're kind of going towards each other. The distance between the cities is that, so that's going to be important. The average speed is, Amy's average speed is 5 more than Chris's. How fast is Chris driving if they pass each other in 6 hours? So again, we're going to have to pull out the information we need and put it in our table here. So the top of the table again is pretty easy. Rate times time equal distance. And Amy was one of our people. And Chris was the other person we're dealing with. Same time, Amy leaves for Washington, D.C., and it says, let's find this. Amy's average speed is 5 kilometers faster than Chris's. So if Chris's is x, Amy's is x plus 5. So that's how they're related. How fast is Chris driving if they pass each other in 6 hours? So how long are they traveling? 6 hours. So again, the distance traveled would be 6 times the quantity x plus 5 here, and 6x here. All right, now again, if we draw a picture of what's happening, let's say this is Washington, D.C., this is Detroit. So one of them's going this way. Oops. What's happening here? One of them's going this way. One of them's going this way, right? So we know that the total distance will have been covered when they pass. We know that total distance was the 510. So the two distances added together should equal that 510. So 6 times the quantity x plus 5 plus 6x equal 510. So 6x plus 30 plus 6x equal 510. Simplifying, I get 12x plus 30 equal 510. So I'm going to subtract 30 from each side. 12x equal 480. Divide by 12. And I get x equal 40. Now again, make sure we go back and answer the question and put a label on it. And the question was, how fast is Chris driving? And Chris was X, so 40 miles per hour. If it would have said, how fast is Amy driving, we would have added 5 onto that. So make sure you answer the question. All right. So here we have Art leaves at 10 a.m. traveling at 50 miles per hour. At 11:30, Jennifer starts in the same direction at 45 miles per hour. When will they be 100 miles apart? So again, my top, rate, time, and distance. We have Art and Jennifer. I'm going to abbreviate Jen so it fits in here. Art is traveling at 50 miles per hour. Jennifer is traveling at 45 miles per hour. Now, what do we know about the time? Well, we know what time they leave, but we don't know the length of time they've traveled, but we do know how they relate to each other. So Art leaves at 10, so he has traveled longer. Jennifer leaves at 11:30. So how much longer has Art traveled? You can either, these problems, it depends upon who you want to do. I prefer to go Art being X, and then she leaves how much later? An hour and a half later. So her length of time traveled is X minus either 1.5 or 1.5. Depends upon if you want to use fractions or decimals or whatever. So any questions on that much, that's the tricky part here. So ask yourself, who has traveled longer? Now if you want, you can have Jennifer's time being X and his time being X plus 1.5. So always ask yourself that question, who has traveled longer, and make sure you get it right. So the distance traveled here would be 50x. The distance traveled here would be 45 times the quantity x minus 1.5. So again, I'm afraid I'm going to run out of room here. I'm going to draw my little picture up here. So here's Art, and he's going this way. And then Jennifer leaves later, so she's behind him, and she's not going to catch up to him because she's traveling. So we want to know when that distance between them is 100. So we would have to subtract their distances. So 50x minus 45 times the quantity x minus 1.5 equals 100. So this is a little bit different type of problem here. So when I distribute, I get 50x minus 45x plus, because I'm taking a negative times a negative there, notice, I'm going to get 67.5 equal 100. So that's 5x plus 67.5 equal 100. So I'm going to subtract, I'm not sure this is going to show up, 67.5 from each side. I'm going to get 5x equals 325, or sorry, 32.5. I'm going to divide by 5. Let's see my decimal in there. Kind of all ran together. And I get x equals 6.5. Now what is that 6.5 hours? But let's read the question. When will they be? So that's like a time on a clock. What time will they be that? Well, you need to go back and see what x represents. X represents the length of time that who has traveled? Art. Now again, if you would have put Jennifer, you'd get a different answer, but you'd put it in and get the same answer when you do the last step. So if he left at 10 o'clock, what is it 6.5 hours after 10 o'clock? Well, it takes 2 hours to get to noon, and we'd have 4.5 hours left. So 4:30 p.m. would be our final answer. So make sure you answer the question that you're asked, because that had a little trick in it then that you had to do that.